Okay, so what we're going to do is take a look at how do Euler rotations work. So to do this, go under File, do New, do Reload Startup File, click on the camera, click on the lamp, do X and delete, click on the object, go to the Object tab, go ahead and enable the axis name, go ahead and switch this to wire, press the 5 key to go into ortho view, go ahead and zoom in a bit, do the middle mouse button to rotate your view, and let's go ahead and open this up. Go under File, do Save As, so we're going to save this as a rotation concepts 5.blend. Okay, so the way the Euler rotation mode works in Blender is that it simply uses a ring-based system to rotate your object. Now we're going to expose these rings to understand how they work internally. But first, what I want you to see here is that we can choose between 6 different configurations. The last axis that is being displayed on all these configurations means that that axis is always going to be bound to the coordinate systems axis that this object is using to navigate in. Because this object has no parent, it is right now using the world space coordinate system. So if we click on XYZ Euler and rotate this object, let's say around the X, now rotate this object around the Y. When we rotate this object around the Z, it will only rotate around the world space Z axis. Now let's go ahead and switch this to an axis where it has the y-axis as the last axis. Now you might have to change the view in a way where you can understand how this is working. Now here, if we rotate around the y, the object is going to rotate around the world space y-axis. Now let's go ahead and choose a configuration which has the x-axis as the last axis. Now let's go ahead and rotate the view like this so we can see how this is going to work. Now when we rotate around the x-axis, this object is going to rotate around using the world space x-axis. Okay. Now go ahead and do Alt-R to reset the rotation. Now, the first axis that is being displayed on these configurations means that that first axis is always bound to the local axis that is being displayed on the origin point of this object. So here, if we choose X, Y, Z, and now rotate around the Y, rotate around the Z, and here if we rotate around the X, it will only rotate around the x-axis because that is the first axis that is being displayed on it. Now let's go look for something that has y-axis as the first axis. Now when we rotate around the y, you can see that it will only rotate around its local y-axis. Now let's go look for something that has z as the first axis. Now when we rotate around z, it will only rotate around the Z local axis. Go ahead and switch this to XYZ and do Alt-R to reset the rotation. Now the question is, what about the middle axis? Now in order to understand this concept, we would have to expose the rings. But basically, a better way to understand this is that it's simply a parent-child relationship concept. The z-axis, which is the last axis, is the parent of the y-axis, and the y-axis is the parent of the x-axis. So when the z-axis rotates, it will also take the y-ring with it, and when the y-ring rotates, it will take the x-ring with it, meaning that when the parent moves, the child goes with it. And if the child moves, it can move independently. Now, to see this concept, what I want you to do is go under File and just reload the file. Now do Shift-C to place the 3D cursor in the center and go ahead and zoom out a bit. Now you're going to do Shift A and add a torus. Let's go over here all the way down, and where it says minor radius, type in .1 and enter. Now we're going to use this ring to expose the last axis, which is going to be really the z-axis because that's what we have chosen. How does it work? So go ahead and click on this object and press the tab key to go into edit mode. Press the 1 key to go to the front view. Go ahead and zoom in. Press the alt key down and click on an edge. Go ahead and zoom out and do the middle mouse button to rotate. You're going to do Alt E and extrude vertices only. Right click to cancel. Press the S key to scale this out. This is so we can see when this torus is rotating. We need something visually to represent that. Now press the tab key to go into object mode. We of course are going to give it a blue color because it belongs to the z-axis. So go ahead and go to the materials and go ahead and click on Neo. Now over here we're using the Cycles renderer. You might be on Blender renderer, but here I'm going to choose a Cycles. Now in order to see color inside the 3D view for this object, we can simply quickly switch over to the node editor and uncheck this. Go ahead and now switch back to the 3D view. Now go ahead and click this and change this to a color of a blue. This is because the z-axis on the 3D manipulator is colored blue. Go ahead and double click in here and just type in a Z. We're just naming the material. Now here we need to tell this ring to follow the location of this object. So let's go to the constraints and let's go ahead and choose a copy in location and just click on the cube. This is so when we click on the cube, the ring follows it. Now what we're going to do is tell this ring to only copy the Z rotation. So here we're going to do copy rotation and go ahead and pick the cube and now turn off the Y and X. The reason we did this is because, as I've shown you, is that because we have this set on XYZ, we know that the Z-axis is what this object is going to use when it is rotating, because it's using the world space as Z-axis. So now when you click on this object and now let's say rotate on its X, rotate on its Y, now when you rotate on its Z, you can see that this is how the ring-based system is working for the Z-axis. So this ring is right now bound to the world space Z-axis. We're basically emulating it by simply only copying the rotation of this object on its Z. Now what we need to do is expose the first axis, right? The first ring. So go ahead and click on this object and do Alt R to reset the rotation. Now we know that the first axis is always going to be bound to the local axis that is being displayed on the origin point. So to do this, we're going to click on this object, do Shift D to duplicate it, right click to cancel, and press the S key to scale. Now when you scale this down a little bit more over here so you have some space for the Y ring that we're going to expose. Now here you can see that when we click on this object, the x-axis is pointing this way. So just like how the z-axis was pointing up and we expose the ring like this, for the x-axis we're going to do the same thing by simply clicking over here and pressing the tab key, pressing the A key to select everything, pressing the 1 key to go to the front view, press the R key, press the control key down and rotate this by 90. Because we only rotated the vertices, we did not touch the origin point's rotation for this object. Press the tab key. Now let's go to the materials tab and click on this too. This will simply make a copy of this material. So it is going to be basically not using the nodes. Now go ahead and double click this and type in capital X and enter. This is just the name of the material. Let's go ahead and change the color to red because that is what it represents, the x-axis. Now over here, go ahead and go to the constraints, and over here we're going to have to copy all the rotations. This is because when the first axis is bound to the local axis of the object, it's basically stuck to it. Now go ahead and click on this object, and now when you rotate around the X, you will see that this is how this is working internally. Here we can rotate around the X, and now when we rotate around the Z, you can see that because the Z is the parent of the Y and X ring, wherever the Z axis, however the Z ring rotates, the Y ring will follow because it's the child, right? Now do Alt R to reset the rotation. Now we're going to expose the Y ring. So to do this, go ahead and click on this object, do Shift D to duplicate, right click to cancel, and press the S key to just scale it down like so. Go ahead and press the Tab key to go into edit mode, press the A key to select everything, and now press the 3 key to go to the right view. Press the R key to rotate, press the Control key down and rotate this by 90. Now press the Tab key to go into object mode. Now here we're going to again go to the Materials tab and click on 2. To make a copy of this, double click this and do capital Y and enter. Now here we're going to of course change the color to green. Now when it comes to the constraints over here for the copy rotation, we of course need to make sure that this Y ring follows wherever the Z ring goes, and we of course want to copy the Y rotation of this object. So here you can see that when we click on this ring, we were only copying the rotation of the cube around its Z axis. And the Y ring, because it needs to be stuck to the Z ring, we have to copy the Z axis from this cube and of course the Y. Now when you click on this object and now rotate around the X, rotate around the Y, rotate around the Z, you can see that how this entire system is working. Okay, so here you can see that because the Z axis is the world axis, when we rotate this object, this is how it was doing it internally. And the X axis is bound to the local axis that is being displayed on the origin point. This is why this object was rotating like this around the X axis. So the question is going to come down to the Y ring. How does this concept work, and how does it give us a gimbal lock? So here what I want you to do is first click on this object, do Alt R to reset the rotation, and here we're just going to make the view kind of like this. Go under File, do Save As, and let's save this as rotation concept 6.blend. Okay, so what I want you to do is go ahead and click on this cube and press the Tab key to go into edit mode. Now when we are looking at this ring-based system, it might not make a sense as to what is the purpose behind this. So we need to give this cube a purpose so we can understand the reasoning behind the ring-based system. So what I want you to do is press the W key and do subdivide. Now you can see that this is where the X ring is. It is locked to the local axis of this object. So go ahead and click on this vertex, which is going to be where the X ring is. Press the 1 key to go to the front view and go ahead and zoom out a bit. Press the E key to extrude out a vertex and right click to cancel. Go ahead and click on this red arrow and bring this vertex out to at least 2 units. Go ahead and zoom in, press the Shift key down and go to where this vertex is. Press the E key to extrude, right click to cancel, and click on this blue arrow and bring it up. Go ahead and click on this vertex, press the E key, right click to cancel, and go ahead and bring it down. Now press the Tab key. So now this cube has a sense of purpose. So you can imagine this cube to be 2 different things. First is that we can imagine this to be an airplane, or we can imagine this to be a cannon. So now when we look at this configuration of XYZ, here we could say that if this was an airplane, when we change the X value, we are simply changing the role of the airplane. When we change the Y, we are changing the pitch of the airplane. When we change the Z, we are changing the yaw of the airplane. Now, if we imagine this to be a cannon, here we could say that the cannon is just rotating around a turret. Here, the cannon is rotating around the Z, and here the cannon is pointing up and down. And here we can also twist the cannon. So here you can see that when we give our objects a purpose, we can understand the idea behind the Euler configurations. Go ahead and do Alt-R to reset the rotation. Now what I want you to notice over here is because these rings are really acting like parent-child relationships, when we rotate around the Z, the Y and the X ring will follow the parent. Notice that there's a relationship of 90 degrees between the Z and the Y ring at all times. When we rotate the Y, you can see that it takes the X ring with it, but there's a 90-degree relationship between the Y and the X ring at all times. So this is why when it comes to Euler rotations, they're best suited to be used with objects that are going to rotate around a single axis or two axes. So if we imagine this to be a cannon again, if we do Alt-R, we could say that we're really not interested in ever using the x-axis. So here we can simply lock this. So now here we can rotate this cannon, or we can point it up and down. See? Now this object makes a lot more sense, because in reality the cannon is not going to be twisted, right? That's the idea behind this concept. Now what I want you to do is Alt-R to reset the rotation. What we're going to do is take a look at this concept of gimbal lock. Why does it happen? So here what I want you to do is go ahead and click on the Z and let's say rotate the object like this. Now what I want you to do is click on this Y and rotate the Y where the X ring is going to align with the Z. Now you can see that we have run into a problem. First is that when we rotate this object around the X, it's going to rotate just like it would have if we had rotated around Z. But notice that what we have done is lost a ring of rotation. See over here? If we go ahead and go to the grease pencil and go ahead and click on a draw, you can see that there is no ring that lets us rotate this object around this way. Press the escape key. Go ahead and remove the grease pencil. So this is where the object is going to wobble when you are creating animations. So the question is, how do we rotate this object around this ring? Well, we have no choice but to change the 3D manipulator and switch it to local. Now we have to force the object to not use the ring-based system, basically tell Blender to rotate this around the Z. So if you press the R key and press the Z key 2 times, you are rotating around the Z. But do you see what's happening with the ring-based system? How it's misbehaving? So this means that if this object is going to be forced to rotate like this, the ring-based system internally is going to be handled by Blender. So what I want you to do is go ahead and make sure that this is on frame 1 and press the I key and capture the rotation. Now go to frame 30 over here and now press the R key, press the Z key 2 times, and let's say we're going to rotate the object like this and press the I key and capture the rotation. But this is how we want the rotation, but you can see that when Blender does it, it wobbles the object. The reason it does that is because it's trying to quickly align the ring-based system so the object can appear in this orientation, right? Internally, that's what's happening to these rings. This is what is gimbal lock. It causes this wobble in your object when you are animating. This means that we had rotated this object on all 3 axes, right? It's really the y-axis that is causing the issue. So we're going to pick this up in the next lesson. Go ahead and just reload this file.